So, this is 129S. We're coming to the end of the semester. There's only a few weeks left. And we're down to chapter 12, which is cross-site scripting. So, all right. Let me refresh this. I added something there. Yeah, good. All right. So, we'll start with the slides and then move on to other things as we go ahead. All right. So, you're going to attack other clients. It's not taking over a server, it's attacking other clients. That's what you can typically do with cross-site scripting. When I see, I should move this over because of my head being in the way. All right, so if you can run script in somebody else's browser, which is what cross-site scripting lets you do, then you can steal their session cookies, hijack their session, and perhaps do other things in their browser, even culogging under certain conditions, get some key presses that are typed into the browser. It's the most prevalent web application vulnerability in the world, and there's various types: reflected, stored, and document object model based. But they all do pretty much the same thing. Reflected is the simplest. The most common is a search engine. You search for something, and the results page has you searched for this. If they don't sanitize it, then it will be there. So I've got an example of a simple one like this here in my browser. There. So here's a simple one. You have a message, and when you submit the message, the next page has that whatever you put in is there. So I put in developer is drunk, that appears as the error. So if I put in like this is a script tag, which will pop up a box, and that is reflected XSS vulnerability. That's the point. Let me see if that zoom in is picked up. Yeah, it is. Good. All right. So that's the point. Since you didn't sanitize data and the data was repeated on the next page, it appears. Now, right now, I only attacked myself, but if I wanted to attack somebody else, I would notice the URL up here has that script message in the URL, so I could send this URL to somebody else, and when they click on it, it'll affect them. And if I don't want them seeing this stuff, I could run it through a shortener like tinyURL, so the link looks innocent. So that's reflected cross-site scripting, the most common type and the easiest type to see. And you can do other things. Here's another one. You can pop up an error. This would be more likely to fool somebody than that nonsense. It's just a demonstration. You can say, error, please go to our new page. And this is actually a link going to a new page, evil.com, which was added. It's not in the source code of this website. It was added from the URL. So I'm able to bounce an attack off somebody's server and create a malicious page that will do something bad, like send them to a bad page. Because of the cross-site scripting vulnerability, I can add code to somebody else's page, which the viewers of that page will then see. And that's bad. And so here's what it looks like. You send the attacker sends you a URL with data. You go to the server, and it has extra data, and the page you see comes partly from this application and partly from the attacker. So I'm able to add code to the page, and now it will do something it shouldn't, like steal the cookies or other secrets from your browser, and so on. So they show this here. You just send a URL that contains data. Like I said, I don't think it's worth going through this because the live demonstration showed it to you. All right. If you have persistent cookies, which is the most common remember me technique, then you already have a cookie, and you might even have a cookie from before. You logged in and said remember me, so there's a persistent cookie in your browser, so I can just request that cookie and it will send it to me. Right now, evil.com cannot get your target.com cookies from your browser. Only a page in the same domain can do that. That's the same origin policy, but cross-site scripting lets me add scripting to the page. So the script came from target.com, and the script will run, and the script can send the data off to a third party. So that's the point. I can't directly get the cookie, but if I can add script to a target.com page, I can get your target cookie. All right. So stored cross-site scripting is where instead of it being in something where I have to put it in the URL and bounce it off the server, I just save it somewhere, like in a Facebook wall post or anything like that. So I got one of these, a vulnerable message board. I think I've shown you this one before. You just put that kind of script in here, and when you view this page, it will run it. So don't think I've got that one here. Let's take a look at the stored XS demos. Yeah, so here I can put in my name. My name is, this is the reflected one. Now I'm in the message board. So in the message board, I can put in this one again, and it will remember that. So now I post a comment, and now anybody that views the list of comments will see that. And I can add another comment here. This is one that will redirect the page, document location. I'm going to erase the old comments and then put in a new comment. This script is going to redirect it to City College's web page. So I post the comment, it shows my page and then redirects, so you end up at City College's web page. And then if I erase comments, another one that's fun is an iframe. I can add extra code in a frame on this page like an ad. So I'm going to put the City College in a box on this page. You have the page from the server, and in this box you should see City College. I don't know why it's not loading. They might have a defense on City College website to prevent this by now. Let me try erasing the comments. And let's try something less protected here like samsclass.info. Or, yeah. See if that works. Looks like it doesn't. Maybe the browser's blocking me. Anyway, all right, so that's the kind of thing you can do. Again, I can add script to somebody else's page, and it will, anybody that goes to that page will run that script. So again, it's the game. The attacker puts the data on the server, and when viewers view the server, the page on the server, the script runs and does whatever the attacker wanted to do to them. Then document object-based model is just a small variation on storage, where instead of having an explicit place it's stored, like a message board, you have code in JavaScript that builds some text on the page from other text on the page. As part of the document object model is how JavaScript refers to text on the page. So there is a place on the page where I can insert script that will show up in the browser. It's a little bit harder to understand, but that's all it is. So I store page elsewhere on the page. And I think I have some demonstrations of this. Let me see. Yeah, here's DOM-based cross-site scripting. So here, if you go here, here's the message, hi, and here's the script that's actually used. The script will go up here. Up here I have a parameter, message equals hi. And that message is read here. This is called document object model, where it goes here and finds it and it puts it on this page. So this is not a literal hi, this is copied from there. So I can take that message and I can replace it by a script. I can put hi, script, alert, 1, script, there. And that should do it. When I just load this page, now it runs the script. So it's just another place to put the script where it ends up on the page. So when you can add these, when it will work, only if they have flaws in the page, yes, that's right. The fundamental problem is anything that takes data from the user has to clean that data before using it. This is the fundamental problem. So if you take data from the user, like addresses, credit card numbers, names, anything, you have to consider that it might be malicious and remove the script tags and so on from it. If you don't, then when you use the data, you're liable to expose the user to this, and that's why it's so extremely common. The most common flaw on the internet, cross-site scripting. Good? All right. So that's the vulnerability. A script the developer but there can, all right, that's the point. It's just so you have a dynamically generated error message, and it can be exploited, as I showed you. So let's try a Kahoot about this stuff. Find the right browser, and the Kahoots are here. There we go. And it's 12A, which is here. All right, the most prevalent web app vulnerability. Cross-site scripting, of course, today's topic. All right, a script in the query string runs on the results page. So what is that? That's reflected cross-site scripting. You type things in the search page, and that runs script in the next page that appears. That's reflected. Which attack can steal session cookies? They all can. The script is the same. The difference between them is just how you injected the script in the page. Once you got script in there, it can steal cookies. All right, which one commonly steals all the data in a database? None of them. That's SQL injection that does that. Cross-site scripting does not give you that kind of power. It lets you steal things from the browser, but typically not from the other apps on the device. All right, and if you use a fake name, make sure you tell me if you want your points. All right, so in the real world, here's some cross-site scripting attacks. Apache had a vulnerability in their issue tracking application, so you could report a vulnerability which would then be examined by the administrators, and so the attacker found they could sneak code in there, and they were able to get the administrator's cookie, and now they were able to modify the code for Apache. So this is very common, like the SolarWinds attack. Awareness is now very high of the dangerous consequences of a supply chain attack like this, where you actually alter a commercial product. So you put on the official version of the commercial product, and an attacker has managed to inject malicious code into that. That's very dangerous. It's very hard for the end user to recognize this or stop it. So they captured username and passwords for Apache privileged user and so on. They were able to take over systems at Apache. It was a bad thing. MySpace, Sammy Kamkar, evaded filters to invade into block cross-site scripting and was able to make everybody who viewed him add him as his friend and copy the script, so he got 1 million friends within hours. It was one of the first really famous cross-site scripting attacks. It was not doing a lot of harm, but it really brought awareness of this flaw. And this one was funny. Strong Webmail offered people a money award, like $10,000 or $1 million or something. I think $10,000 if you got into his email, because it was one of the first emails with two-factor authentication. So he said nobody can hack in, even if they get their password. They have to get like an SMS on my phone. But what they did, somebody checked in, attacker looked and found that if you have your home device, you can check a box saying, don't bother sending me a message on my home device because it's trusted. So then you just sent a PDF file to him saying, I won. The PDF file contains the proof. When he opened the PDF file, it ran a script and stole his cookie. And so he hadn't hacked into him, but then when he opened that file, now he had hacked in. So he got in. Twitter had 2 cross-site scripting worms slam them in rapid succession in 2009. And this happened over and over. So you can do a lot of things with cross-site scripting. You can do more than just steal cookies. You can add extra content to the page. Like I said, you can add images. You can add looking frames with other pages inside them, or code of any type. All right, so you've seen this. We've already looked at this. All right, so you can inject actual working functionality into the application. You can add code. This is something that keeps on happening to shopping carts. People find a vulnerability so they can add malicious code to a shopping cart. It keeps happening to Magento shopping carts, and a common service used for shopping. There are vulnerabilities on the pages where people can add code, and now when you shop, it sends an extra copy of your credit card number to the bad guys. So you can add, here is looks like a DOM-based object model. You have a parameter up here called COL, and this parameter just has a whole bunch of URL encoded stuff. There's a whole bunch of data there, and that data is being used for something on the page. So this data in the URL is making this fake form, which is not from the user. And this form says Google will become a subscription service costing $5 per year. You have to fill in your credit card number and so on. So this is an attack. They'll make a fake, very good-looking page, and the actual content of this page is up in the URL where the user will probably not notice it. So in session hijacking, you steal cookies and getting people sessions one by one. That's labor intensive if you have to monitor your server and collect the cookies. So it's better than session hijacking, though you log in with somebody else's cookie, is to just do whatever action you want in their browser. So maybe you want them to buy your book at Amazon. You can just make a script that will execute that command in their browser. So the payload script will do things. That's what the MySpace worm did. He didn't hijack people's sessions. He just added a script where they would add him as a friend and then put the script in their page so other people get infected. So it just did the attack right there without having to go back to the attacker for a second layer of action. And that's nice. If you can automate the action, then of course it will move faster and it will not leave as many traces back to you. So the question is, does your browser trust the source of this script? And of course it trusts JavaScript from the same website, and autocomplete can fill in fields. Some sites require being added to trusted sites in Internet Explorer. I imagine Edge is still working that way, I'm not sure. Anyway, there's issues of what code your browser will trust, but cross-site scripting is very dangerous because the added code appears to come from a trusted source. And ActiveX is an old technique that Microsoft has pretty much abandoned their competitor with Java. And so there's other things you can do. You can log some keystrokes, capture browsing history, sometimes even port scan the local network from the browser, although these things are pretty limited in what you can do from the browser. The main thing you do is steal the data stored in the browser. All right, let's take a look at another Kahoot. Okay, which attack earned a $10,000 prize? Strong webmail. All right. Which one did Sami Kamkar do? Very famous hacker. space for it. Which one gained administrative access? That was the Apache exploit. They didn't just send the cross-site scripting to another user, they managed to send it to the administrators and steal their cookies. All right. All right, which one is labor intensive, requiring the attacker to collect cookies one by one and use them? That's session hijacking. All right. Okay. All right, so the ways to deliver these attacks. You can send a phishing email or an instant message containing a crafted URL to, that contains the modified URL that will have this extra text. Instant message, you can post code on a website where you click some link and that link contains extra information. And there's watering hole attacks, which were first named when China did this to Tibetans. Instead of like sending messages to the target, you just make a website of interest to them and then have malware on it and wait for them to come to that site. You can use search engine optimization to attract them and so on. This is a technique, like in the wild. You put poison in a watering hole and then wait for someone to wander by and consume it. So you could also purchase ad space and put malicious URLs in the ad. And websites often have a tell the friend or sell feedback, so you can use that to send an attack. This just happened to Office 365. Microsoft had a page that you could use to report information to the Office 365 administrator, like technical flaws, and they were able to exploit that to send email that appeared to come from the administrator of Office 365 and send spam to people, which would be trusted and not blocked by their spam filter because it came from a trusted source. So you can, like I say, deliver these things. In-band is the most common. You have the names of documents included in the request. You can also have something else other than viewing the target app, like you get email from the server. So the victim doesn't even have to go visit that website. Something comes in, like an email. And you can chain cross-site scripting. Very often, cross-site scripting itself is not taken seriously because by itself, it doesn't let you take over the server. But it does let you take over someone's account, and then you might be able to do other things, and typically it's part of a chain that leads to a more dangerous exploit. So you might be able to allow script into a user's displayed name, and then an access control flaw lets you change other users' names, so you're allowed to put token stealing and cross-site scripting in every username, and then you get all the users, and eventually you'll get the administrator user, and then you can take control of the application. That's the sort of chain where you have a weak attack combined with other flaws to add up to a very dangerous attack. So to find these things, the simple way is just insert a script like we've done and insert it all over the place and see if things pop up, but this won't find them all. If the simple attack fails, the applications might have some filters, removing the script tag or less than, greater than, or other special characters, so you might be able to craft the attack by just making it sneakier, like use upper and lowercase mixed, use URL encoding for the special characters so they get by, put a script inside a script, so if they have one layer of removal, they'll create another one, put a null character in front of it, hopefully that the defense mechanism is written in C and will interpret this as the end of the script, but the web server will not be written in C and interpret that and take all the code. These are some of the tricks we talked about before to slip things past defenses. There are also cross-site scripting attacks that don't simply return the attack string because the input string is sanitized or otherwise modified. So you might have to deal with that it does some kind of alteration of the inputs that go in. So I say put in a benign alphabetical string everywhere and just find everywhere where it comes back. And then for each of them, see what you'd have to do to run a script. It might be inside an image tag or something. You might need to put in quotes or an angle bracket to break out. That's the idea. So choose a unique string like this and submit it everywhere and see where it comes back. And any place the string you put in came back is a place where you might be able to put in script, which would come back. And that's the game. All right. So here's another demo of these things, which I pretty obvious. Here, for example, I got an image resizer. So if I submit it, it shows me this image at 50% size. And you see those numbers are up here. And the point is, I could, if I look at the source of this page, all right, and zoom in, you'll see here's 50%. And remember, I control this number, but it's inside an image source tag. So if I just put in the same kind of attack we've been doing, like here, if I go there, if I go back here, and I've tried to put a script in here, like script alert 1/script. All right, I'm all going to put it in a clipboard. You always want to do this when you're doing this kind of work. Save it in a clipboard because you very often have to modify your attack. So I put in the same kind of injection we've been using, and I submit it, and the injection does not work. And the reason it does not work is, let me view the source. It's there, but see, it's inside the height parameter, so this is not interpreted as a script tag that will run a script. It's interpreted as part of the height parameter. So what I have to do is I have to add a apostrophe and a greater than sign to break out of this tag for it to work. So let's try that. If I go back here and I add an apostrophe and a greater than sign there, I think that will do it. Now I submit, and now the script runs. And the reason the script runs is because I finished the height parameter, and now the script is out here on its own being interpreted as a running tag. So that's the kind of thing. That's what they were talking about in their recommendations there. All right. All right, so I talked about that. And here's another one. If it returns your data here as script inside a variable, then again, you just have to give it the right punctuation marks to terminate the stuff, like this apostrophe, and then put in the right code. You have to customize the code to match the code around it so your script will run. Here's an attribute containing a URL. So it's going to appear in an ahref, so you can use JavaScript to make your script into a URL. That's one way to do it. You can also use the on-click event handler. I think I got some more demos of this stuff here. Let's see. If I go back, yes, let's see. Here's JavaScript string. So I have foo when I submit it and view the source. I hear foo is here in a variable. So inside a script tag, but in a variable. So what I have to do is inject this stuff. That's the stuff to terminate the previous code. So this alert one will run and then fill in the remainder just so it won't be a syntax error. So when I put in that, now it runs again. And the reason it runs, if you view the source, is that now I put in some code to finish this first line, variable equals A, then alert one, then variable B equals. So, you just have to customize your attack to fit the surrounding code the developer put there to make the code that you're putting there run. And I think, now here's a URL. So if I submit this, the URL is there, and if you click, you're going to go to City College. So if I view the source, it's inside this ahref. So the way to exploit that is this. You put in JavaScript alert one. That's one of them. Now that's a valid URL. And it looks okay, and when you click it, it's going to run JavaScript. You can see it in the page source. Just have JavaScript in there. That's one way to do it. And the other way is with an event handler, which is here on click. So you put in the URL, then an apostrophe and a space, and then you can have another parameter inside the ahref tag, which will take effect. So now it looks good when I move over it. Oh, it should, maybe it's when you click. Yeah, when you click, it takes effect. Okay. So that if I look at this, view page source. Yeah, it was on click. So on click, it will run the script. Now, the one I thought I was doing, which I guess I'll do now, is on mouse over. Instead of click, on mouse over. There, that should do it. Now you have a page, and when you move the mouse over it, it runs the script. So these are just various ways to run JavaScript on a page. All right. And here's one where it blocks script tags. So if I run script, alert run script, and submit, it doesn't run. And see, here's what it does. It detected a script tag. So I view the page source. Okay, it detected a script tag, so it didn't come in. But it's not very smart, so there are ways to do it. Let's see if this one works. Some of these, this one here puts the script tag inside a data field, which may or may not fool it, depending on how it's looking for script tags. Let's see if that one fools it. It doesn't do it because I'm using Chrome. I don't think the second one will work either, but the third one will work in Chrome, where I use base 64 encoding of my script tag. And that used to fool Chrome. And let's see if it fools this browser from Portswigger. It looks like it no longer fools it. All right, anyway, as time goes on, the browsers get smarter about these attacks and block them, so they don't keep working forever. All right. And so there's various kinds of defensive filters. It identifies an attack signature. It does some kind of sanitization or truncated it to a fixed length. And as we've seen, you can defeat most of those if you're clever enough. Signature-based filters, you'll see some kind of error, and you have to modify your attack until it no longer is picked up by the defense mechanism. All right. So let's try another Kahoot, which is here, 12C. All right, the switch attack posts a malicious page and just waits for targets to visit it naturally. That's watering hole. You just make it tempting and hope they will just go there. All right, what cross-site scripting displays script that did not come from the server? I don't like this question. I'm going to make a note, because it seems to me like they all come from the server. So I'm sorry, I can't change it now, but I don't like that question. I think it's a bad one. Let me make a note. Kahoot 12C. All right. I no longer think that makes any sense. Apparently I did when I wrote this question, but now I'm not seeing it. All right. See if there's another question here. All right. If you control the value parameter, what injection will work on this code? There's the code. Okay, input value equals foo. All right. yeah, this one, you're going to need the double quotes to fill in the missing, to finish it and have an on focus. This is the event handler solution. All right, this won't work because it's inside a parameter. It'll be interpreted as just data, and it won't be interpreted as a script to run. All right. All right, let's see what more we have here. Okay, so ways to introduce scripting. You can put in script tags, but if you can't put them in, here's other ways to do it. You can refer to, you hit an object data, we saw this, you can encode it as base 64 or other ways to hopefully bypass that sort of thing. And you saw this live in a demo. And then there's event handlers on ready state change, on mouse over, on error, on click, on focus in. You know, it's just a bunch of these event handlers. So when the user does certain things, it'll run the JavaScript. HTML5 has ones on focus and blur, which is when you're pointing to something, when you're not pointing to it, enclosing tags on mouse move, and so on. There's just a lot of these JavaScript things to inject. And you can use JavaScript protocol wherever a URL is inspected, and it will run the JavaScript instead of going to the web page. All right. And you can have dynamically evaluated styles. So you were able to put it in a cascading style sheet. You're able to put JavaScript which will run, which is kind of nuts. You can bypass filters. If this on error is going to get filtered, then you can try putting in a capital M here, or you can put null bytes in to try to stop it from getting caught by a filter. And that's the point I mentioned. Null bytes terminate code written in C, because in C, a null byte terminates a string. But in other languages, it doesn't. So you might be able to get the web app filter to not notice it, but it still is noticed by the application and runs. You can have invalid tags too. Like here you have an invalid tag /x. This is perfectly legal in HTML. You can have unknown tags because it'll just say, well, this must be a tag from some other version of HTML. It'll just ignore extra tags. So it's harmless to have extra tags, and it might perhaps fool a filter to have extra tags there. You can set base of the attacker here, and then when they have scripts later that just refer to a location of a file without specifying the directory, the base will now point to a different directory than the developer intended, so it'll load from your malicious server instead of from the local server. You can put a space following the tag name. You can replace the space with other characters, image/image in these other brackets. That way, the image on error will be interpreted as just one word, and it won't trigger a filter that's looking for image space on error. You can also add extra characters where there's no space. After the slash in script, you can put some junk, and that might block the filter looking for script tag, but it'll still run. You can put null bytes in the attribute's name. So this on error will not be interpreted as on error by a C-based code. You can use backtick instead of a double quote, and that might fool them. That's why it's so easy to slip past filters that try to have a deny list of bad things. There are so many ways to modify the bad thing to not match the list of known bad things. So you can use backticks instead of quotes, and that get rid of the space. You can also eliminate the space that are supposed to be there in quite a few commands, and it will just work anyway in many browsers. All right, you can UR HTML encode characters, put in a null. There are many, many tricks. You can use decimal and hexadecimal format of a character, 6C to be the L in alert, I think is what that is. There's all different ways to write an L. And you can sometimes perform URL decoding twice, so you can use %25, which will be decoded, to turn into %. That'll be %3C, and that'll be decoded to turn into a less than sign. So you sneak in this forbidden character as innocent characters that are later interpreted that way, and they may be translated into this after the filter. instead of before the filter. You should do all translation before the filter, but often that isn't the way our servers are set up. Some unusual Unicode characters are accepted, so you can use these weird things, double less than and double greater than, and the browser will interpret it as less than and greater than, but the filter may not. And you can have extra brackets. And here's another one. You can, this one will let you do it. This strange format is accepted by Firefox where you don't even close the first script tag. So, you know, this is many, many tricks. There's a web developer add-on you can put in that will show you what the HTML turns into when Firefox tries to fix the code, and that would help you discover some of these strange things. And there are character sets available for everything. There's UTF-7 and US ASCII, and UTF-16 are all various ways to encode letters as bytes, so that a forbidden character can be encoded as some numbers, which may not set off the filter. You can tell the browser which character set you're using with a variety of parameters. And there's also this bizarre thing called Shift JIS for Japanese characters, and it lets you have 2 bytes per character. So what you can do is input 1% F0. This starts a 2-byte character, and when it's used, it will begin a 2-byte character, so the next character that the developer put there will be removed. So you can use this to remove a character the developer put there, the quotation mark. So that's kind of crazy. You have input 1 and a quotation mark, and then input 2. I want to get rid of that quotation mark. I start this Japanese character, and it eats that quotation mark. So that's pretty bizarre. So to bypass the filters, you know, you can try all these techniques. Encode your stuff as Unicode, use eval to encode it as, again, Unicode or other encodings. Put in extra escape characters, extra backslashes where they're not needed. They won't stop it from running, but they might stop the filter from recognizing it. And you can use A to B, ASCII to binary, and binary to ASCII. That's JavaScript that will base64 encode and decode stuff. So you can put in this thing will take the Unicode, take the base64 encoded stuff and turn it into script. So it may, again, the filter may not be able to do that translation. And you can dynamically construct strings. You can build them bit by bit. Here's A to B, which will take this base64 encoded string. And you can also have character codes, number by number, and so on. Ways to build a string that would be forbidden and blocked by the filter. You can use other things beside eval, like replace and other functions to do it. You can, all right, I'm not going to worry about the dots. All right, anyway, all right, I think that's enough of this. It gets a little overwhelming. There's just so many ways to sneak in. That's why filtering out bad stuff is not a good plan. What's much better is to only accept known good stuff. Have a known good list of characters and only let those through. That's the safe way to do it. Trying to filter out all the bad stuff is a nightmare, because there's so many ways to change the bad stuff. VBScript, Microsoft has now removed it, so I'm not going to bother with that. So there's ways to do it. You can, when you want to, sometimes characters are sanitized. You want to let them use less than or greater than, so you just turn them into the HTML encode, which will look like a less than sign on the screen, but it won't have the effect of starting a script tag. So you can find out which characters are sanitized and try to use the remainder. Sometimes you're already in a script, so you don't need to add a script tag. You can use all kinds of techniques to sneak it in. If it doesn't remove all instances of script, you can just put in 2 scripts and one of them will still remain. If it's not recursive, you can remove script and the new thing after that still contains script. If the first filter ships script recursively and then object recursively, you can do this. It's not going to remove this because it isn't script, but it is going to remove object, and that creates script. So the fact that they do 2 stages of filtering and then don't go back and see if the first stage needs to be done again, will get them. All right, and here we talked about injecting into an event handler. We've done it before with the on-click and such. And if you have length limits, if you can only send short data, then there are ways to shrink this down. And there are sort of contests I've seen online of how you can make the shortest cross-site scripting attack to fit into a really small field. And there's a JavaScript packer that'll pack them down and make them smaller. You can also perhaps find multiple injection points where you can put part of the attack here and another part of the attack later in the code. And you can like start a comment string and end a comment string to comment all the code in the middle, so your pieces of your attack will be combined together. All right. And you can convert a reflected cross-site scripting to document object model if you put in the fragment string. This will view the fragment in the URL, and so you can put that up in the URL with a pound. That's called a fragment. The part of the message after the pound. Here's a pound here and an alert there. So there's a way to use document object model to move something large in if you can't directly put in large input data. So, that's examples. And I say this may seem like an overwhelming bunch of little picky tricks, but the way to learn it is to do the projects in the Web Security Academy. You'll get practice with these things in simple contexts, and it gets easier to understand the ones that are useful. So let's do the last Kahoot, 12D, which is here. All right. All right. Which attack has the first part of a 16-bit character in it? That's Shift JIS, that strange Japanese system. All right. All right, which character may cause a filter to stop working? That's the null byte. Will be interpreted as the end of a string in C. All right, what function decodes scripts written in base 64? ASCII to binary. It's not binary to ASCII because ASCII is the base 64 stuff. The stuff you encoded could have been binary. And that's why ASCII to binary is what decodes it. It seemed backwards when I first learned about it. After a while, you get used to it. All right. Very good.